recording. We'll get our recording started. And there are already a couple of requests in the chat to take a look at a couple things. One, I will just start with an apology that I have not posted the last couple of class recordings to Canvas yet. So I will take care of that this weekend and then send an email out to everybody. That's why you can't find them. But there's also a request to go through quiz 3. And if you haven't had a chance to look at the notes that I left, don't just look at your score. Go in there and actually look at the comments that I've left. Because for each problem, you know, if you lost points, I'm writing something about why you lost points. But let me pull up the quiz questions. Sorry, I did not have them printed in my office. I'm not sure if there are any particular questions that people wanted to go over, but let's go ahead and start with a couple of the questions that there were lots of people that made mistakes on. So again, graphing is just one of those things that is not going away. So the first question on the quiz was plotting points, and for the most part, people did great with that. The second question, and this is from quiz 3. The second question, I think there was some confusion over the way that it was phrased, and it should have looked like some of the homework problems. But again, just in terms of looking at the way it was set up, we were asked to find to complete the ordered pairs, and the ordered pairs were listed like this. And one of the things that I want to point out, because it wasn't just a problem on this question, but it was a problem for several people on different questions. When we write points for a graph or the equation of a line, or gosh, the equation of anything, when we're writing points as an ordered pair, that first number in the ordered pair is telling me the X value. And the second number is telling me a Y value. So this question, oh, sorry, that's not a 0, it's a 2. So this question was basically saying, hey, I'm giving you half of the ordered pair. I'm either giving you the X value or the Y value. And you need to figure out the other point that's going to make this true. All of these were messy. They all led to fractions, but fractions doesn't mean you're doing something wrong. Fractions show up all over the place. And I don't know why I wrote y equals 0 in this. That is clearly a 1. So let's just pick one of these. If I do that second point, what we needed to do was plug in 1 for y. So this would look like 3 times x plus 4 times 1 is equal to 9. And a few people made like arithmetic mistakes or computational mistakes is how I've listed it in the scoring. But we should have 5/3. Also, that's the correct answer, and we should leave it as 5/3. There is no reason to put that into a calculator. Fractions are really the better answer because that's an exact answer. And if you put it into a calculator and you have to round, it's no longer an exact answer. Just kind of as a general statement about computational errors that happen, I'm making a big deal about them now because the number one thing that I hear from students when they walk out of a pre-calc or a calculus test is, I would have had a better grade if I just hadn't made those small mistakes. So I really am encouraging you all to take this quarter to invest the time to get those perfect scores. to really make sure that you're taking the time to figure out what you need to work on so that you aren't making those computational mistakes anymore. If the time for my office hours is not working for you, and if you can't find individual appointments that match with your schedule on my calendar, please, please, please shoot me an email. I have other times in the day. I will make time to meet with folks, but this is the quarter to like figure this stuff out so that you can move forward and do well. Okay, so back to the quiz. I don't know if there were, let me go back up in the chat. I don't know if there was a specific question from the quiz that someone wanted to go over. I don't see a specific question, so I'm just going to keep going with questions that I saw several people have mistakes with. So the third question on the quiz, we had to find the equation of a line. And it needs to have a slope of 2 and go through the point 3, 6. The number one wrong answer that I saw was to treat this like it was telling us the y-intercept. It's not the y-intercept because this is saying x is equal to 3, y is equal to 6. So it's not an x-intercept and it's not a y-intercept. It's just a point on the graph. So if I saw these, the choice I would make is to write this as y minus 6 is equal to 2 times x minus 3 using the point slope form. Totally fine if you want to use the slope intercept form, but I didn't give you the intercept, so you'd have to work for it. So if you wanted to do y equals mx plus b, what you would have to do is to recognize that the slope was 2 and then use this point to solve for the intercept. And that's totally fine to do as well. So using this point to solve for the intercept would look like plugging in 6 for y. We know the slope is 2, plugging in 3 for x, and then solving for b. Well, it turns out that b is 0. So the final equation, if you were writing it in slope intercept form, would just be y equals 2x. Or if you like 2x plus 0, but there's no reason to write the plus 0 part. Other problems where, like other questions where people made mistakes on some of the other problems, I would say those are actually the two where lots of you made mistakes. I think on problems 4 and 5, some folks missed the fact that the instructions asked you to sketch the graph. So people found the points, but didn't actually finish graphing. But I'll just give everybody a second. Are there any other questions from the quiz that anybody wanted to go through? Yeah.
I don't think it's a question on the quiz. It's just like a general question.
Yeah.
So we're allowed to like leave the. We're allowed to make the equation that way, right?
For sure. You can totally write the equation like this and then walk away from it. That is a completely valid equation of a line. That's a valid equation of a line in calculus. Save yourself the time. Don't bother rearranging it. Just walk away. Yeah. By the way, this is also totally valid and fine to do. Yeah. I'm not seeing any requests in the chat to do any other particular questions from the quiz. I'm happy to go over some. If you think of one in a couple minutes that you really wanted to do, pop it in the chat and we will return to this. But for now, I want to move on to multiplying polynomials. If you have a little bit of time this weekend, I don't know if this is still a thing that people do in school. When I was in elementary school, we had these mad minutes where, like, I think they were called mad. Yeah, they were definitely called mad minutes, where it was like you were testing multiplication and addition facts. And there's like a whole sheet. And for us, we would like have a competition in the class of how many people could get through in 1 minute, and then the teacher would grade them. I'm not kidding. The number one thing you could do for yourself this weekend, we're going to be starting factoring on Monday. The number one thing you could do for yourself is review your multiplication and addition facts. I know that sounds, I don't know, tedious or dumb or something, but it is so helpful in terms of getting faster at factoring, to be able to quickly recognize what the factors of some of the larger numbers are. But that's where we're headed Monday. Today, we're going to talk about multiplying polynomials. And we've been doing some of this already, just thinking about working with exponents. So if I have something like 3x squared times 4x to the fifth, technically I'm multiplying two monomials there, the 3x squared and the 4x to the fifth. Because everything I've written is multiplication, we can rearrange things. And I would choose to rearrange this to group my numbers together so that I've got 3 times 4, and then group my x's together. 3 times 4 is 12. And then when I look at these x's, I'm going to use that additive law of exponents. I'm multiplying two things with the same base, so I add the exponents together. And I've got x to the 7th. If I have different variables in the mix, like let's say I had 2y squared x times 3yx squared. Everything that I've written is multiplication. There's no addition or subtraction in here. So when I think about multiplying, I'm going to regroup this to group my numbers together. Have 2 times 3, group my y's together. I've got y squared times y, and group my x's together. I've got x times x squared. You don't need to write out this extra step for me. If it's helpful for you to see, then absolutely my recommendation is to write it. But I don't need to see that intermediate step. The invisible exponent on that y is a 1. So y squared times y would be y to the 3rd, or y to the 2 plus 1. Same thing's going to happen with my x's. That invisible exponent of 1 plus 2 gives me 3. And that's the most simplified that I can get. A lot of the times when we're working on problems in pre-calc or in calculus, we're not just going to have multiplication happening. We're going to have situations where we have to remember to distribute. So if I had 3x squared, and then in parentheses, 4x, 4x plus 6. The thing that makes this different from the previous problem is right here. It's the addition. That's telling me that I don't just have multiplication in this problem, and I actually need to think about distributing this out. So I'm going to take that 3x squared, and I know that that needs to be multiplied by 4x. And it also needs to be multiplied by 6. There are different ways that we can sort of express going from here to here. One of them doesn't really have a name, but a student suggested a name to me years ago and I've kept it. So one way of sort of keeping track of what you're doing is the rainbow method, meaning I'm going to draw rainbows to show that I am distributing in that piece from the front. Once everything is distributed out, then each of these pieces are all multiplication. Now I can regroup things, combine variables. So here, 3 times 4 would give me 12. And then I'm going to look at my x's. X squared times x, I'd have x cubed. Over here, the 3 times 6 is going to give me 18. There aren't any other x's, so I've just got x squared. Another method for sort of keeping track of how we're distributing things here. Sometimes people call it the box method. And I can draw little boxes. So I have 3x squared, that's one monomial. And that's being multiplied by 4x plus 6. And what I would write in each box here is, we can think about it as like the area of the box, but it's the multiplication of the two sides of the box. So 3x squared times 4x would give me 12x cubed. 3x squared times positive 6 would give me positive 18x squared. And then I'd write my final answer by adding all the things that are in the boxes together. Now, I don't usually take the time to write out the box method if I just have a monomial times something in parentheses, but the box method is helpful when I have a polynomial times a polynomial, which is where I'm going next. So I'm looking here at two things that are both in parentheses. There's multiplication between them. And inside of the parentheses, I've got this addition and subtraction. When I go to multiply these two pieces together, there is an acronym that has sort of become a verb when people talk about math. The acronym that has become a verb is FOIL. And it's possible that you've heard FOIL before. It's okay if you haven't. But this and this are the first terms, because they're the first term in each of the parentheses. So this acronym of FOIL stands for first, outer, inner, last. I personally don't use FOIL, but I'm up for whatever gets you through the day. So first means I'm going to take the first term in each set of parentheses. So that would look like x squared times 3. The outer is referring to like, this is the outside most and this is the outside most. So I would have x squared times negative x. Inner would look like 1 times 3, because they're like on the inside together. And last would give me the 1 times negative x. We would simplify all of those and add them together. So I would end up with 3 times x squared. X squared times negative x would give me negative x cubed. 1 times 3 would give me 3, and 1 times negative x would give me negative x. if you were trying to check your answer with something from the back of the book, the back of the book is going to reorder these in descending powers of x. So it would reorder these to say negative x cubed plus 3x squared minus x plus 3. Personally, I don't care which way you write the final answer. I'm keeping an eye on the chat for questions. Please, please, please slow me down. Question in the room. Yep. Yep.
The answer would be 30x to the 6th power because if it's adding, then you would multiply.
So we would leave this alone. So the question was going back to the previous problem and like, can we combine these two things? So we talked about this a little bit on Wednesday, but when we say the term, when we say that phrase like terms or combine like terms, that means that the exponents have to be the same. So I can't combine anything with an x cubed and an x squared because those exponents are not the same. So unfortunately, it's kind of like backwards. When you multiply things, you get to add the exponents, but when you add things, you don't get to do anything at all. So when you're adding two terms, if they don't have the same exponents, you can't combine them. But that's a good question. Yeah. Okay, so let me come back to this because I said I don't actually use FOIL. Personally, most of the time I use the rainbow method, but there are times when the problem looks complicated and I go for a box. So if I were going to do this by what I am calling the rainbow method, I start with one of the terms in the first set of parentheses, and I draw rainbows to distribute it through. So I'd have x squared times 3, and I'd write 3x squared. And then I'd draw my rainbow from x squared over to negative x. X squared times negative x, I know it'll be negative. Squared times another x would give me x cubed. Then I come through, and honestly, I'd draw like underground rainbows or something. Smiley faces, smiling things, I don't know. But I would take the next piece here and distribute it through. So I'd have 1 times 3 and get a 3. 1 times negative x and get negative x. Option 3. Option 3 is that we draw a box. I've got 2 pieces and 2 pieces, which means my box needs to have 2 pieces on one side and 2 pieces on the other side. Then I would come through and multiply the sides to get each entry in the box. So this box has sides of 3 and x squared, so I get 3x squared. This box has sides of x squared and negative x, and I get negative x cubed. This box has sides of 1 and 3, and this box has sides of 1 and negative x. And then finally, we put all that together so that I would have negative x cubed plus 3x squared minus x plus 3. And I will say, if you've taken the time to do the box, when you write your final answer, you might as well put it in descending order of the powers of x, because that's the way that it's going to show up in the answers in the back. I will pause for a second in case there are questions. Question in the room. Yeah.
The negative x, it has an invisible,
Yeah, and so those invisible exponents, just like the invisible coefficients, it's okay for you to write in the 1 if it helps you to remember. Mathematically, the reason that we tend to not write in the 1, and this is like super, super subtle, but okay, we'll see if I can even manage to write it. Those mean different things in calculus. So this one we would read as x prime. And it means we're doing something to it calculus wise. And so because of that, notation wise, we just don't mess with it. Because I don't know about your handwriting, but my handwriting is not neat enough to keep the difference between these two. And so that really at the end of the day is why mathematicians don't write the 1 in for the exponent. Because we have this notation that looks almost the same, but means something very different. Okay. Moving on, let's do some more examples. A lot of the multiplication that we're gonna do, like the vast majority of multiplication we're gonna end up doing for calculus is stuff that looks like this. 2 pieces multiplied together, each of the pieces has 2 things separated by addition or subtraction. Getting fast with the multiplication and addition facts also helps with multiplying stuff out. I'm gonna go rainbow method. You go whatever you want on your paper, right? So I would say practice everything. So decide, are you a FOIL person? Do you like to draw in rainbows? Do you like to draw in boxes? But find whatever's gonna work the best for you. So here, I'm gonna take that x squared, distribute it to the 2, and distribute it to the x squared. I'm gonna take the -3, distribute that to the 2, and to the x. And one of the things I didn't mention on the last problem, because it wouldn't have really applied, is once we've multiplied these things out, we do want to combine like terms. So looking at what I have written, I have 2 terms that have the same powers of x. So those are the two terms and the only 2 terms that I can combine together. So writing this in descending order, I'd have x squared, and then I can combine the 2x and the -3x. So 2x minus 3x gives me -x, and then -6. And that would be my final answer. So I'm going to give you all 1 to try on your paper. If you are hanging out with me on Zoom, I'm going to switch the chat so you can't accidentally talk to everybody. You can only send your answer to me, but I'm going to give you 1. And when you have your answer, go ahead and type it in the chat. So let's do +4 times. So multiply it out and then combine your like terms. Meanwhile, I'm going to pop into the hallway because there's a drinking fountain outside and I need a drink. Not that kind of a drink. I need a sip of water. So far, I've got one answer in the chat. How are we doing? You got an answer? That looks like the answer I see in the chat. Okay, I got 2 answers in the chat. I'll wait for a couple more. Okay, I'm up to 5 answers in the chat. Most of them are looking the same, just kind of mixed up in different orders. Let's go for it together. This one I'll do box method style just to change it up. So I'm going to draw my box, and I've got 2 pieces and 2 pieces. So I'd have X and a +4 and a 5 and a -X. So this box has walls of 5 and X. This one, a -X and an X, so that'll be -X². A 5 and a 4 will give me 20. A 4 and a -X would give me -4X. So if we've drawn it as the box method, then when we write it out, we can go straight to descending order and having combined like terms. So here, I've got my -X². And then when I combine the 2 like terms that I've got 2 things with X's. So 5X and -4X, when I put those together, that'll be a +X, and I have a +20. Good times. By the way, this is algebraically completely equivalent to putting these in another order. So I could have written these as 20 + X - X². I could have written this as X - X² + 20. I'm not going to write out all the possible ways that I could scramble these up, but they're all equivalent. Okay, let's get another example rolling. And we haven't done any where we have more than 2 terms. So let's do one more. I've got more than 2 terms. So X² + X + 1 times X - 1. We'll do this first one together. Sure, let's do this one together. If I'm going like rainbow style here, it's gonna get a little messy, but it's okay. Oh, by the way, that phrase FOIL, or the acronym of FOIL, one of the reasons that while I will use FOIL it as a verb, meaning multiply the things out, if we have more than 2 terms, there isn't really a first, outer, inner, last, because I have more than that. So the acronym fails us, which is why I tend to not use it. But I'm going to start with that X² and distribute it out. So X² times X, I'd get X³. X² times -1, would give me negative x squared. I'm going to use different colors. That's how I'm going to keep track of it. So I'm going to take my next term of x and do the same thing, distribute that out. So I've got x times x, which would give me positive x squared. I've got x times negative 1, should give me a negative x. And then my third term here of that plus 1 times x would give me a plus x. And 1 times negative 1 would give me a negative 1. Now, if I come through and combine like terms, mine are kind of already stacked up in a nice order here, but I have two terms with an x squared and negative x squared plus x squared. Well, that's a 0. And negative x plus x, that's also a 0. So when we put all this together, it actually simplifies really nicely, and I just have x cubed minus 1. And that would be my final answer. And let me give you all one to try. So how about a minus a squared plus 4 times a squared plus 1. So give it a shot, multiplying that out on your paper. If you're with me on Zoom and you think you have an answer, go ahead and put it in the chat. I'm going to do this one as a box method just because I did the last one. Oh, sorry. Knocking my camera around. I'm going to do this one as a box method. So I'm going to set up the box, but I'm going to give you all time to do the multiplication on your own. So if you wanted to try this as a box method, not seeing any answers on Zoom yet. I'm going to give it another minute. How are we doing? Yeah, yep, yep.
sure.
Yeah, those invisible ones.
I just wanted to make sure.
Yeah. Okay, I've got a couple answers on Zoom. Maybe I'll go ahead and start writing this in. So if I start, I said I was going to do the box method this time, so I've already got my box written out here. The walls of this box are a by a squared. So that's going to give me a cubed. Then I'll have a by 1. Negative a squared times a squared. I know it's going to be negative. And a squared times a squared would give me a to the 4th. Negative a squared times 1, I'll have negative a squared. 4 times a squared, that's a positive 4a squared. And 4 times 1 would give me 4. So if I look at all of the things in my boxes, there are only 2 that we would consider like terms, because there are only 2 where the exponents are the same. So these are the 2 that I would want to combine together. So if I do this in descending order, I would have negative a to the 4th plus a cubed. Those a squared terms, I've got 4a squared and then a negative 1a squared. So overall, that's going to give me a positive 3a squared plus a plus 4. Questions about any of that before we do another example? Pausing to see if questions are coming through on the chat. Or if typing questions is difficult, you can always unmute yourself to ask the question. But I'm not seeing questions pop through on the chat. So let's do another example. We can always come back to this one if a question occurs to you. Like I said, most of the time, the type of multiplication that we're going to do is going to look like we have 2 terms being multiplied together and each of the terms have 2 pieces. This is the bulk of what we do in pre-calculus and calculus in terms of these multiplication problems. So these are the ones that it's important that we get fast with, or faster with. Fast but accurate. So I'm just going to give you, yeah, let's see. I'll start a timer. I think we ought to be able to multiply this out and combine like terms in 1 minute or less. That's okay. Okay, that's about a minute. I'm not trying to like pressure folks in terms of the timing, but when we encounter something like this in a pre-calculus or calculus setting, this is like one step in a much larger problem. So we want to get faster at the algebra part so that we can focus on the other stuff. So here, if I go rainbow, I've got 2x squared times x, that's 2x squared. 2x times 3, that's plus 6x. 1 times x, that's an x. 1 times 3, that's a 3. Someone in the chat asked if you have to show any work on these or if you can just do it in your head. Totally fine to just do this in your head, as long as you're getting them right. And if you're not getting them right, then there's no opportunity potentially for partial credit if you haven't written anything on the paper, right? But yeah, ultimately it would be awesome if you were doing them in your head quickly and accurately. Now, once we start multiplying polynomials, there's a thing that happens in your brain, and you start to see multiplication in places that it doesn't exist. So let's say that I had x plus 5, and then we had x minus 3. I mean, I know why this happens, but number one common mistake that someone's going to make here is that your brain sees parentheses around that x plus 5 that don't actually exist. So this problem, we need to follow the order of operations. The only place where we have multiplication is between the 5 and the parentheses. So this problem actually says we have x plus the result of multiplying this out. So my 5 distributes to the x, and my 5 distributes to the -3. And we actually have 6x minus 13 as a final answer here. Next, yes, good times. 3 times 5 is in fact 15, not 13. But it is super common for our brains to make that mistake. So just something to kind of look out for as you're working through some of the homework problems. But let's say that I have 1/2 x plus 3 times 4x minus 1. I know I put fractions in there, but it's okay. Fractions are your friend. We've got just about a minute left, so I'm going to go ahead and work through this. But if you want to like tune me out, turn your volume off. You could just ignore me and see if we get the same final answer. I'm going to do this one as a box method because I haven't done a box method in a little bit. So 1/2 x and a plus 3 and a 4x and a minus 1. So 4x times 1/2 x, that's 2x squared. I'd have a -1/2 x. 4x times 3, that's 12x. 3 and -1, that's -3. So I would have 2x squared minus 1/2 x plus 12x minus 3. Well, if we're going to combine like terms here, I have 2 terms with an x, but one of them's got a fraction, which means I'm going to need a common denominator in order to combine these 2 terms. So that 12, I really want to think about as saying 24 over 2x. So when I put those together, I've got 23 over 2x. Oops, sorry. Yeah, so I multiplied the 12. I didn't really have space to put it in there, but I multiplied the 12 by 2 over 2 so that I got that common denominator with the 2 on the bottom. And it looks like I am out of time once again. Gonna go ahead and stop